Hey guys, it's Mr. Canada. Today we're going to be going over the second section of our chapter relating to sequences. Today we're going to be specifically talking about arithmetic sequences and looking a little bit more in depth about what they're about. So, let's go ahead and talk about what we're going to learn today. Today what we're going to learn about is we're going to learn to identify the different parts in the formula of an arithmetic sequence. We'll learn how to use the formula of the sequence to find the terms. And finally, we're going to learn how to write the formula of an arithmetic sequence. So let's go ahead and recap what we already know about arithmetic sequences. So last time when we were talking about arithmetic sequences, is that arithmetic sequences deal with only addition and subtraction. The common difference tells us whether we're always going to be adding or subtracting by that number to continue our list. And finally, the different spots of the sequence are called the terms of the sequence. So just remember that in order for something to be an arithmetic sequence, you have to be able to see if the common difference is the same. So let's go ahead and look a little bit more in depth, and let's look to see how the formula of the arithmetic sequence actually looks like, because we will be using it a lot today. So this is the formula of an arithmetic sequence. It has a lot of working parts, but let me just talk about the ones that are important. This first part right here, a sub n, remember that we were going to be talking about sequence notation a lot more. This a sub n is what we call the general term. Not general like in the army, but general as in it could be anything. So how the general term helps us is that we can use the general term to help us look out for a very specific term in our list. Now that's very useful because what if they're asking us to find a really big number in our list? We can use a general term to find that number directly and not do a whole lot of work. So that's the beautiful part about using the formula, is that it'll take out a lot of the heavy work that we normally have to do. Because if we didn't have a formula to work with, we would have to be working it out by hand a couple of times just to get to the 30th spot on the sequence, which would take a while, because what if I gave you a bigger number, like 100? Then you don't want to be doing that work by hand every time. So the other important piece here is this piece right here. Remember that last time we were talking about a sub 1? Remember that that's the first term of the sequence. It's the first spot on your list, okay? And finally, this little guy out here. That little d out there is what we call the common difference. So you already know about that. Remember that we were talking about it last time. This is where you would normally put the number that represented your common difference. So there are three working pieces here. The general term helps us out in figuring out a very specific spot. The first term tells you exactly what the first number in the list is, while little d is basically the number that we're always adding or subtracting by. So keep in mind of where these pieces are located, because we will use this formula later in this video to write something that fits a sequence. But for now, let's look at a very basic arithmetic sequence, a formula that fits that arithmetic sequence, because it looks way prettier than what we have on the screen right now. So for example, let's say they gave us something like this. Use the formula to find each indicated term number. So look how nice and simple the formula actually looks. It doesn't have all the pieces that we had in the previous slide because somebody, or mathematically, it's already been worked out and simplified for you. So at the end, after you simplify, you're always going to get a nice answer that looks like this, which is good because then the math will be a little bit easier, more simple to work with. So what exactly do they want with this type of example? They're basically asking us to use the formula a sub n equals 2n plus 3 to figure out what numbers are in each one of these spots. So basically, if you were out, let's say, waiting in a line to go to checkout, they're asking which people are in these three specific spots. The first spot, the third spot, the fifth spot of that line. So this is where we're going to be using the formula. It's actually very simple. All you have to think about is this. Look at the number that's given to you for each term And that's the number that you're going to be plugging in order to find out the number for that specific term. So for example, let's work with the first one, a sub 1. What you guys need to focus on is this. Focus on the little number at the bottom. That little number is the number that you're going to plug in for the letter n in this equation over here. Like I was saying, the general term will tell you immediately, specifically, what number is in that spot. What spot are we looking for? Well, we're looking for the first spot, spot number 1. How do we find spot number 1? You take that 1, you plug it in. So a sub 1 is equal to, we're going to go ahead and plug in 1 for the letter n. 2 times 1 plus 3. All you have to do now is simplify. 2 times 1 is 2, plus 3 is equal to 5. So what does this tell you? This tells us that the first number in our list is going to be the number 5. How did we get there? All we did was we used the formula that they gave us. We plugged in the number that we're looking for and got out the number that's in that spot. That's all you have to do with these types of formulas. Look at the next one. We want to look what number is in the third spot of your sequence. Why third? Because it's the number 3 here. So guess what? We're going to plug in the number 3 for n. So a3 is equal to 2 times 3. Notice that this time we're changing it to a 3 because we're trying to figure out what number is at spot 3. And again, from here, you multiply and simplify. 2 times 3 is 6, plus 3 is 9. So that means that a sub 3, this entire thing, the number that's at the third spot would be the number 9. Make sense? So notice how we're just doing this. We're just taking the number, we're plugging it in, we're getting an answer out of it. That's basically how these formulas work. Straightforward and simple. Look at the next one. A5. If you had to take a guess, you would think, we're going to be plugging in 5 this time, and you would be right. So a sub 5 is equal to 2 times, this time because the number is 5, we're going to plug in 5 here, plus 3. Multiply and simplify. 2 times 5 is 10, plus 3 is 13. So this is going to be equal to 13. So that means that a sub 5, the 5th spot on our list, will be equal to 13. I'm going to write it here on the side. It's going to be 13. So anytime that they are asking you to use the formula to find the indicated term number, all you're really doing is just plugging in the numbers that are given to you into the formula and seeing what the result is, and then writing down that result. Let's go ahead and keep going. So let's think of the opposite. Let's think about situations where, well, what if they already give you a list of numbers? What if they want a formula out of it? Let's go ahead and just keep it super simple. Let's think about what we have to do here. If you want to write a formula for that sequence, you have to keep in mind that we're going to be using the formula that we saw at the beginning, this guy. You only have to look for 2 important pieces of information in order to write the formula. You only need to look out for the first number in your list, which sometimes will be given to you, sometimes you're going to have to figure that one out, and you have to find the common difference, which again, sometimes it'll be given to you, sometimes you're going to have to figure that out. Lastly, after you have those 2 pieces of information, we're just going to plug them into the formula, and then we're going to simplify, and then we're not going to do anything else besides just simplifying it. Let's go ahead and see how that works out in action. Example B. Write the arithmetic formula given the first term and the common difference. You know what I would do every single time that they're asking me to write an arithmetic formula? I would write down what that formula looks like. So the formula looks like this. A sub n, a1 plus n minus 1 times d. You only care about looking for a1, the first term, and looking for the common difference d. That's all you care about. In this particular problem, notice that they already gave us what a1 is equal to, and they already gave us what d is equal to. So guess what? All you have to do from here is just plug it in, and then we're going to simplify. Check it out. So here's a sub n. We're not going to touch that. They tell you that a1 is 15. So that means we're going to go ahead and plug in 15 there. Plus, we're going to keep this the way it is, n minus 1. They tell you that d is negative 2. So we're going to go ahead and plug in a negative 2 here, times negative 2. So notice that we're already going through the first steps. We know what a1 is, we plugged it in. We know what d is, we plugged it in. Now we're just going into our final step. We're going to go ahead and simplify what we have left over. So a sub n, we're going to bring down that 15. We're going to take it step by step just to keep it simple. We're going to take this 2 that's on the outside here, and we're going to multiply. We're going to distribute that negative 2. So if we do that, look what we get. Negative 2 times n is negative 2n. Negative 2 times negative 1 is positive 2. From here, we just combine like terms. So a sub n is equal to 15 plus 2 are like terms here. So that gets us 17. So 17 plus, or actually let's just say minus 2n. Now why minus 2n? Because it's already minus 2n in our expression. So how do you know if our final answer is our final answer? Well, here's the thing. They're asking for a formula that fits the arithmetic sequence. Remember the first example that we did a while ago. This is an example of an arithmetic sequence. So as long as you get an answer that looks like that, then you are doing the right steps. You are getting answers that look that way. So look, it looks exactly like the one we did before. So we would say that this is the formula for the arithmetic sequence that was given to us on this slide. Notice the few steps that we did. The only big steps here were finding what a1 was, figuring out what d was, plugging them in, multiplying, and then combining stuff to finish off our problem. But what if for a1 is not given to us? What if the common difference, little d, is not given to us? What do we do then? Well, let's go ahead and look at a situation like that. Write the formula of the arithmetic sequence. So now, keep in mind what you have to do here. In my opinion, I feel that you should always write down what the formula is so that you are already giving yourself a skeleton of where you can plug stuff in, okay? Like a formula skeleton. So here's our formula. Our formula, remember, is a sub n, a1. You know what? I'm gonna give myself more space. I'm gonna write it up here. an, a1, n minus 1 times little d. Now, notice that they're straight up not telling you what a1 is and what little d is. So you have to think about this. a1, remember, is the first number, the first term on our list. So if they give you a list here, ask yourself, what is the first number in my list? Well, the first number in my list is 6. Well, guess what? That 6 is going to be the first term. That's going to be your a1. So I'm just going to write down on the side here that A1 is going to be 6 because it's the first number in my list. Now the only thing you have to figure out now is, well, what's little d? Well, we've done practice on that before. In order to find out little d, you have to ask yourself, what number am I jumping by each time to get from 6 to 1, from 1 to negative 4? If they tell you that something is arithmetic, you don't have to check every number. Just check the first two numbers. Think about this. My numbers are going down. Arithmetic only deals with addition or subtraction. So if my numbers are getting smaller, that must mean I am subtracting. So think about, what number do I have to take away from 6 in order to get to 1? And the answer would be negative 5. This negative 5 is your little d. This is your common difference. So now you have both the pieces that you need in order to finish this problem. And you know what? I'm gonna go ahead and write this on the side here, negative 5. So you have all the pieces now. You're subtracting 5 from 6 to 1. That's going to be your difference. That's going to be your little d. So now, where do we go from here? Well, let's just recap before we move on. If they don't give you the first term of your sequence, then you have to look out for that on your own. Easiest spot to look for is that first number on the list. Afterwards, look at the first two numbers. Ask yourself, how do I get from first number to second number? We're only talking about addition and subtraction right now. Because my numbers were going down, I had to subtract. So you should be expecting minus whatever for your little d. Okay, let's go ahead and finish this off. So we have all the pieces we need. an equals, we know a1 this time is 6, plus n minus 1 times negative 5. That's what little d is on the side. We multiply and simplify. We take this negative 5 and we multiply. We have a sub n equals 6 plus negative 5 times n is just negative 5n. Negative 5 times negative 1 is plus 5. From here we just simplify and we're pretty much good to go. A sub n equals 6 plus 5 is 11. And then we just bring down that minus 5n. And here's your formula. This problem requires you to look out for the information yourself, but it's not hard to find that information. If you want the first term, look at the beginning. If you want your common difference, remember what that means. That's the number you're always adding or subtracting by. So check those first two numbers. Ask yourself, how do I get from 6 to 1? We subtracted 5, okay? If your numbers are going up, that probably means your common difference is going to be adding this time. That's it for today's video. I hope you guys learned something new today. If you have any confusions or you have any questions, please shoot me an email or leave a comment on the Google Classroom. Besides that, I hope you guys take care, and I'll see you guys next time. Take care, guys.